Jonathan Kruger. I'm with the IOMC Secretariat, which is hosted at UNITAR, and I'll be your moderator for the webinar today. And this is the third in the series of World Bank and UNITAR webinars. And so I'd like to very much welcome you to this event. The topic for today's meeting will be electronic waste and unintended persistent organic pollutants, or POPs. The focus will be looking at POPs emissions from e-waste and how this can influence policymaking and the development of legislation. E-waste is considered hazardous as it contains toxic materials and can produce toxic chemicals when treated and recycled inappropriately. The mismanagement and inferior recycling of e-waste is a threat to public health and safety. And of course, the open burning of e-waste generates and openly releases POPs, including dioxins, furans, and PCBs. And although the rate of countries implementing e-waste policy, legislation, or regulation is slowing down, all of the Africa Environmental Health and Pollution Management Program countries have developed policy instruments or updated their laws in relation to this. So during this webinar, we'll be outlining data on POPs emissions, how these link to e-waste, and providing examples of how this has prompted changes in policies and legislation. I'd like to remind you that interpretation from English to French is available during this session. And so as you can see on the screen, you can select your preferred interpretation channel. Please press or choose that language and then select either original audio or French for your preferred channel. And if you do not see this option, you can select more at the top of your screen, language and speech, and then the interpretation language. So with that brief introduction, I'd now like to open the webinar and hand over to Mr. Paul Martin. Paul is the Practice Manager for Environment Operations for Eastern and Southern Africa at the World Bank, and he'll be providing the opening remarks for this session. Over to you, Paul, please.
Thank you so much, Jonathan, and a warm welcome to everyone joining us for our Environmental Health and Pollution Management Program webinar series with UNITAR today. We turn our focus today to the release of unintentional persistent organic pollutants, POPs, from burning e-waste, in other words, electronic waste, and links to policies and legislation. In many countries across the African region, e-waste continues to be managed informally. One of the most common practices is the open burning of cables, circuit boards, and plastic components to recover copper and other valuable metals. And while this activity provides an income for many households, it comes at a high cost to health and the environment. Open burning of e-waste is a major source of POPs, such as dioxins, furans, and polychlorinated biphenyls. These substances are highly toxic, persist in the environment for long periods, and they travel far beyond the immediate burning site. Workers involved in informal e-waste recycling face some of the highest exposure levels, and studies show elevated urinary polycyclic aromatic hydrocarbon levels among those workers, along with more frequent reports of respiratory symptoms such as coughs, chest pain, and breathing difficulties. Once released, POPs accumulate in soil, dust, sediments, and food chains. This means exposure is not limited to workers at the e-waste sites. Entire communities, including those who have never directly handled electronic waste, can be affected through contaminated food, water, and air. Children and pregnant women are particularly vulnerable to POPs exposure. Exposure during pregnancy and early childhood is linked to impaired neurodevelopment, endocrine disruption, reduced vaccine response, and long-term effects on growth, learning, and cognition. Evidence from communities living near informal e-waste sites in Africa has shown the presence of POPs in blood, breast milk, and umbilical cord blood, demonstrating that exposure begins before birth and continues into early life. The broader health and economic impacts are significant. The total social costs associated with acute respiratory infections in children under the age of 5 that is attributed to e-waste sites in several African countries are estimated to reach about $300 million by 2032. However, at the same time, we are seeing significant policy and legislative progress in a number of African countries aimed at addressing these risks. And I'd like to give you a few examples. So in Tanzania, Tanzania has established a comprehensive legal framework governing the generation, storage, transport, recycling, and disposal of e-waste across the country, and that was in 2021. All e-waste activities require permits and prohibit certain hazardous substances and assign responsibilities to manufacturers and consumers. Ghana introduced an eco-levy on electrical and electronic equipment in 2018 with revenues managed by the Environmental Protection Agency to support formal e-waste recycling infrastructure. Building on earlier incentive schemes that paid scrap dealers to turn in specific e-waste streams, Ghana's e-waste fund had accumulated more than 5 million by April of last year, enabling the establishment of new collection and treatment sites offering cash incentives for safe e-waste return. Kenya anchored extended producer responsibility policies within its Sustainable Waste Management Act in 2022. Producers will have to declare volumes of products introduced in the market and plans on how they will handle them when their use ends, including recycling. Kenya started enforcing the management of e-waste in 2025 under the Electronic Equipment Disposal, Recycling and Reuse Bill, regulating how electronic waste is collected, transported, sorted, recycled and reused, while assigning specific responsibilities to both national and county governments. Senegal updated the Environmental Code in 2023 to control management of hazardous waste, including e-waste, reinforcing restrictions on hazardous waste movements and improving regulatory oversight of electronic waste. Senegal had aimed to recycle up to 90% of its e-waste by 2025 and is launching new dedicated e-waste collection and dismantling centres. Finally, last year, Zambia opened their first formal e-waste recycling facility to recover valuable materials like copper, helping reduce toxic open burning and environmental contamination, turning e-waste into economic value under Zambia's extended producer responsibility framework. We know we have a long way to go and many challenges to address, but we're not short of solutions. We're short of implementation at speed and scale. Today, we will hear from Heidelor Fiedler, a UNITAR expert who will present on POP's emissions data and how these link to the development of legislation and policies. And following this, we will hear from Kees Balde, also of UNITAR, about how monitoring e-waste can generate the required data to inform policy. We look forward to hearing more from our presenters and panelists today on POPs and e-waste, as well as responding to questions. I very much hope you will find the session both enjoyable and informative. Thank you. Back to you, Jonathan.
Thank you very much, Paul. I think your remarks really underscore the importance of why we're discussing this topic today. It's not only the health and environmental impacts, but also the economic impacts of e-waste and unintentionally produced POPs that are our concern. So thank you for those remarks. I'd like to move then directly to our first presentation for this session. As was mentioned by Paul, we have our first speaker is Heidelor Fiedler, a senior expert at UNITAR. Heidi is also a scientific collaborator at the chemistry department at the University of Liège in Belgium, and she holds a PhD from the University of Saarland in Germany. She's a former senior scientific officer from the United Nations Environment Program. And while at UNEP, she developed the standardized toolkit for identification and quantification of dioxin and furan releases. She's authored a number of studies and is joining us today as a senior expert advisor from UNITAR. And her presentation will be covering the issue of POPs and e-waste data. How can they influence policy and legislation? So over to you, Heidi, please.
Yes, thank you very much for inviting me to participate in this meeting and for giving the opportunity. Actually, for me, it's a first time that I'm participating in such a UNITAR webinar. I hope you can see the presentation now.
Not yet. There it is. Yes. Please go ahead.
It's there or not? Not?
Yes, it's good.
Yes, okay, fine. Because I cannot control that. Yeah, thank you very much. I'm, as was mentioned, I'm a chemist and not a regulator, not a lawyer or something like that. And from that point of view, I'm used to read texts carefully and see how what is expressed and what is expected. And I think in a connection with the with legal obligations under mainly two conventions, I would like to mention here that is especially important. This here is the overview. I briefly want to go into definitions and regulatory implications, and would like to start with WHO, who have summarized some key facts. That is of October 2024. You see the webpage there, and I must admit I do not have the basis for all the numbers that are given there, and that might be already one of the bit difficulties between science and policy and regulation. But they state that about 62 million tons of e-waste were produced globally, and only 22% about are formally collected and recycled. And I think that is one of the major issues, these informal sectors. According to the WHO, lead is the most common substance associated with e-waste and environmental impact. So that's a bit different than unintentional POPs, what we are discussing here. And from that point of view, the combination unintentional POPs and e-waste is not a natural one. And I can also say at the time when the negotiations on the Stockholm Convention started, e-waste was not an issue when unintentional POPs were mentioned. The informal e-waste recycling activities have the adverse health effects, as was stated just in the opening, and they also mention and refer to the international legally binding agreements, which are the Basel Convention on the transboundary movement of hazardous wastes and their disposal, and but also what is important for Africa and for the Pacific Islands, the regional conventions, the Bamako Convention and the Waigani Convention. The Basel Convention is really the legally binding instrument where e-waste is regulated. The Basel Convention is one of the first of the chemicals and waste conventions and has 191 parties. Have to remember that the UN has 194 member states, so all but 3 are there. And then there is the ban amendment, which has a bit less of parties, and the regulation, and there is a definition on e-waste in the Basel Convention, which reads there as electrical or electronic equipment that is waste, including all components, sub-assemblies, and consumables that are part of it. Of course, what is a waste and what is a stockpile might have some legal implications in the different countries. And should be mentioned that at one of the last Basel COPs in June 2022, the annexes were changed, some were amended, and others were deleted. And from that point of view, especially for legal implications, please consult these. When we have the Basel Convention, what is here written in red, the technical guidelines on the environmentally sound management of POPs waste, e-waste itself is not found there. And from my point of view, that is a bit a break between the Basel and the Stockholm Convention, perhaps. But it's all work in process, and I can only encourage countries to actively work on these technical guidelines to get further information. When we see that, you see there the parties to the Basel Convention, and I think that is really mandatory to all countries except the United States. And I think we know that. The other would be the South Sudan, and in another part, and Haiti is not a party. The ban amendment has not where the e-waste is regulated. It has not been ratified by so many countries, but a large number of African countries, perhaps half of them, are parties, others are not party to the convention, and therefore have their legally binding obligations. So it's really to look into for the implementation. When we go to the term persistent organic pollutants, we must say it was not invented by the Stockholm Convention. It goes back to the 1980s when the term first came up in that scientific publication in chemosphere, and it was related to water, what is typically not what we understand today under POPs. Even older is a scientific publication that talks about characteristics of POPs, and they have there the large industrial production use, the tendency to bioaccumulate, pronounced persistent and high toxicity, and that is very similar to what is written in the Annex D of the Stockholm Convention about the POPs characteristics. And these would be those to evaluate or to define POPs as we do mostly today. And with that, we come to the Stockholm Convention with 186 parties, which are shown there. Relatively similar picture as was for the Basel Convention, but Malaysia, Brunei, South Sudan, Haiti, Israel, and Andorra. These are the UN countries, and Timor-Leste, which are not party to the Stockholm Convention. So for them, the treaty is not legally binding. Yes, here to finish off on that with the POPs history. So when we talk about POPs, we mostly mean what is understood under the Stockholm Convention on POPs, but we must be fair. We have to write that is that definition, because, for example, already the UNECE also includes PAHs, which is not in the Stockholm Convention. So we have a bit an issue with POPs definition. And so which chemicals are considered to be relevant in e-waste? We had lead, what was mentioned in the by WHO. We have the PCDD, PCDF, the dioxins and furans, which are the only unintentional POPs that are only unintentional POPs and not others. Right now, there is under discussion the polybrominated dibenzodioxins and furans. We have the polybrominated diphenyl ethers, which are also largely regulated in the Stockholm Convention, the polychlorinated biphenyls, the polybrominated biphenyls with the hexabromobiphenyl. These four groups are in the annexes of the Stockholm Convention, but not included are the PAHs and mercury and copper. Mercury would be found under the Minamata Convention, another legally binding instrument, and copper perhaps. So we have to define which is the most relevant of the chemicals in e-waste. When we go to the toolkit, and as was mentioned, I was among those who developed the toolkit. We have there in the source group 2, under the reporting requirements of countries, of parties to the Stockholm Convention, the source group number 2, ferrous and non-ferrous metals. And therein, the title under the subgroup 2L is thermal wire reclamation and e-waste recycling. That would be the place to report e-waste, how it is being disposed of, including the e-waste recycling. And we have emission factors to the air, but not to the other 4 vectors, which should be reported. And it is always so that the class 1 is the highest emission factors. That is a totally uncontrolled and open burning of cables, but also other e-waste of circuit boards. And then the class 4 would be when it is done in a proper industrial installation with flue gas cleaning, and you see the big differences in the emission factors, how much microgram of dioxins, furans per ton of material treated are being released. So that would be the one place to report e-waste recycling in as it is in the reporting requirements of the Stockholm Convention under Article 15, which you should report every 5 years. For explanation, there is a TAF, the TEQ approach for the risk management. I will not go into detail, but that is how the numbers should be generated. And there is also the results can be found for the on the dashboard of the Stockholm Convention, and it is shown here for unintentional POPs. I have put out that here, and to note there is an error in the Stockholm Convention webpage. It says kilogram per year, but actually the numbers are in grams per year. So there is an error of a factor of 1,000. I have mentioned that very often, but they don't change it. So you should report emissions of unintentional POPs as dioxins and furans in TEQ to air, water, land, product, and residue. And that is then shown up on the web page and can be seen by all of them. The toolkit is done so that it has 10 major source categories or source groups, whereby the 10th is not quantitative. And I have just talked about the ferrous and non-ferrous metal production, the group 2, with the 2L, to report that here on an aggregated basis. But then there is also the open burning, which was mentioned just in the opening, which is a major concern and the general issues also of research and regulation or non-regulation, where e-waste is also can be in there. And I will report about a project where we have determined emission factors. All that is laid down in the toolkit in the latest version of 2013. That is adopted version for reporting. And already in around 2010, we had a project on dioxins, furans from open burning of waste. to determine emission factors for the toolkit from biomass and waste in developing countries, and China and Mexico were the two developing countries. And in comparison with the United States and Sweden, we did undertake laboratory and field experiments, and first had to characterize the wastes, and then developing technology on sampling for the determination. That was a more than 2-year long project, and had quite a lot of new research being done. We had the different samples, and electric and electronic waste was not a very typical one. First, we had to define what is rural waste, RR, UI, that is urban industrial waste, and semi-urban waste. And then we had in Mexico urban industrial waste amended with electronic waste. So what we found in rural waste, they would not burn, very rural waste would not be burned at all because it's far too wet and is being composted. So it's only the urban industrial waste that is high in plastic, where then also co-combustion of electronic waste would occur. We have done field experiments with 100-kilogram batches, and you see there, when we see how much dioxins and PCB is being generated from that, it was not the highest emission factors. When there were bad combustion conditions with a lot of organic materials, wet waste, then the burn was not so good, whereas with the urban waste, with a lot of plastic and combustible materials, the emission factors were for PCB and for dioxins and furans were in the lower range. Still a lot, but not so much. And so from our point of view, we the toolkit in the category 6 was for the open burning of waste and accidental fires was amended, not specially for e-waste, but we had the combustion conditions on compacted waste and more loose waste. And you see here these emission factors, which in the open burning were lower than in the open cable burning of the category 2, which I have shown before. So if there is no walls and no hindrance and a good ventilation, then that is not the worst conditions. And these were here some of the experiments to see how it was being done, how we have sampled there. And you see there was open flames, but not all the time. And the smoke plume was collected with these amended waste there. And that allowed us to quantify the dioxide emissions, but it's up to the countries what they report. And the most important, of course, is to give the mass, how much is being burned in such a facility, in such a setting. Another project which was not at all so much about the unintentional POPs was in China. This was a UNDP GEF project, which did run from 2014 basically to 2021. Unfortunately, I do not have final or publications or project reports for that. I was the evaluator for the project, and the objective was to reduce the POPs and persistent toxic substances during waste electric and electronic equipment. That maybe is coming closer to the management part and not so much to the emission part. You see here, it was managed by FACO and the Ministry of Environment in China, and the implementation and that is what is here. The main objective was to change the current informal sector to replace or be absorbed into a new formal sector. That was the policy step that should have been achieved, and by setting up financial incentives, also including the private sector, and eliminate the also large volumes of imported e-waste, which of course increased the problem in the country, and not only dealing with their own waste, but also having imported, and then yes, define WII and apply best available techniques and best environmental practices to the Chinese context. So larger one.
Could I just jump in with a time check, please, Heidi? Could I just jump in with a time check? About 3 to 4 minutes, please. Thank you.
Oh, okay. I thought I had till 45. So what was being done? There was BAT and BEP implementations, and what they have done, they have also included the public sector, the electronic, for example, the setting up apps, and also included Baidu, which is the largest search engine in China, to have that report to collect the waste and all of that. So for the production, consumption, recycling. So this is a typical waste management life cycle, public awareness, and then strengthen policy and capacity building. They have set up collection stations for private e-waste, transportation, the dismantling, which is still a lot in lines mechanically, and then disposal up there, and had done a lot of public awareness, and but also especially these collection stations, and where they could use apps to deliver private electronic waste. Just briefly on the global assessments, which I would say, and I must say, I did a lot of monitoring project under the global monitoring plan for the Stockholm Convention till 2010, and we cannot trace back the e-waste sector in anything. These are the global emission inventories for dioxins and furans. It is very busy, but you see the countries here, which different sectors it would be the light blue and the red, which are the interesting ones. But it is only 77 parties of 186 have done an emission inventory under the Stockholm Convention. So there is a huge lack of reporting by the parties. And from here, we can see that open burning is important, but we do not know what is coming from from e-waste, even if we assess the data according to the different source groups of the 10 or 9 source groups, which I have mentioned before. So from Africa, we only have 12 inventories of 43 parties from Africa, but it does not look better for the other regions as well. So that is, and many inventories are not up to date at all. That is certainly a lack which should improve, but that's a Stockholm Convention issue. When we look into ambient air, when we're looking for the dominant pollutant in Africa and the Pacific Islands and Gulag, the areas where we have done the investigation, still DDT is by far a dominating compound in the Pacific Islands. It's dieldrin, and dioxins, furan play a minor role. So we cannot trace that through the effectiveness evaluation. And the same is in human milk. DDT is the most important compound, and the PCB is still somewhere there, but it's from intentional POPs, and others are increasing. So yes, we cannot control it with effectiveness evaluation and like that. So my conclusions would be to strengthen policies enforcement, that is, implement the Basel Convention, the prior informed controls for all the e-waste, and enforce Stockholm Convention obligations to eliminate or restrict POP-containing materials, replace informal recycling, develop formal collection and recycling systems, and use extended producer responsibility to integrate, apply BAT and BEP for the POPs reduction, which we have under Article 5 and Annex C of the Stockholm Convention. Improve monitoring and laboratory capacity. If you would like to control, you must have the necessary tools there, and then also enhance data and awareness and innovation to make it a bit more common sense and not an abstract academic issue or policy issue with a vision that cannot be achieved. Thank you.
Thank you so much, Heidi. And I think your presentation really takes us into the fact that there's a lot of science, there's a lot of data underneath the fact that unintentionally produced POPs and their links to e-waste is a serious matter. But I also appreciated your images that showed us some the cases of the open burning in Mexico and the e-waste collection in China, and trying to make this as real as possible. I'd like to move on quickly, and we will have a chance for questions in a dedicated session later. I will say for those of you that have asked for the presentations, they will be made available on the website. So you can check in the meeting chat for the website at which you can find the presentations and the recording of the session afterwards. We'll come to detailed questions on the presenters in a later session. So with that, I'd like to move on to our next presenter, and that's Mr. Kees Balde. He's a senior scientific specialist at the Sustainable Cycles program, which is hosted by UNITAR. And he was the initiator of the e-waste monitor series, the co-founder of the Global E-Waste Statistics Partnership, and the scientific coordinator of the Future Availability of Secondary Resources Horizon Europe research project. He's a member of a number of global expert groups on circular economy, waste, and sustainable development goals, and acts as a speaker and expert providing advice to governments. And the topic of Kees's presentation today will be e-waste and POPs data for policy development. So with that, Kees, over to you, please.
Thanks a lot, and also very happy to present to you virtually on my presentation. So today I'll talk about e-waste and how important data is, and how you could gather data and how to make sure to link this with the policies which you have to make. You may see some of the slides which you may have seen earlier somewhere else, so my apologies for that. So a bit about our about our team. We are Bonn-based from UNITAR, and we have a great team with whom we're working on research and statistics, on the global monitors of e-waste, on statistical guidelines, and we also build capacity for national players and for researchers how to make their own statistics on electronic waste, on plastics, and on batteries. And we also use our data, which we're having at the national level, at the product level, for further advice for legislation. And one of the key projects we're doing right now is the legislation from the European Commission on the WE Directive, which is always leading globally in advancing the field of e-waste management. I think we all know, if we have bad data, we make bad information. And with bad information, you have bad or not even policies, because you don't even know what you have to manage. And if you don't have policies, you have no funding. What to address the issue which you want to tackle. So therefore, it's and with bad funding, you will also not have any good data. You will have also have some bad data. So this is so if you have no or bad data, this is a negative or a downward spiral if you want to address the problem. So therefore, it's very important to change this downward spiral into a positive one. And I hopefully will show you how you could be doing this, and also one example from a country where I have been working with. So why do we need statistics on e-waste? I think we have to monitor the developments over time. We have to divert the flows which we do not want. And if you are to make any legislation, it's very important to have targets, and these targets, they should be measurable. Because if we're having targets which are measurable, you can also track way better if you're making progress and what you can do in order to make the progress at the national level. At the same time, if you're compiling statistics on e-waste, you can also use them to report them for the Sustainable Development Goals, but also for the source inventories which you may have to make for Basel, Stockholm, and Minamata Convention. Well, I think we all know now that we have to monitor this at the national level if we want to address the problem. So how can we do this? Maybe a short recap. It's a very diverse waste stream. So therefore, we need to start with understanding what's the composition of our products. We have a measurement framework which consists of 54 different products. It's the UNU keys, and we want to know what is inside each of those products, which components, which materials, and which elements, and which toxic substances. Which you could get from the literature. We have published this in our statistical guidelines, or also you can also sample it yourself. So this is one example how it would look like for a laptop. There's some cables, some hard disk drives, and we want to make the bill of the materials of an average laptop throughout the world. If we know the product composition, we have to understand the stocks and the flows. How much is placed on the market? How much is sold every year? How much is in stock? Or what's the lifespan? And how much e-waste is being generated in a particular year in a particular country? You could use the official statistics from the trade statistics, from the production statistics to gather your data and to convert these numbers into the desired statistics which you need to make e-waste statistics. And many examples and how to actually do this is in these statistical guidelines which we have published in February of this year. It's the third edition, by the way. It's strongly rooted to the official statistics, so every country in the world can make data. There is no excuse that you cannot make data, because every country in the world has a trade statistics data which you can convert into making data for e-waste. If you know how much e-waste is being generated, you need to understand how it's being collected and managed. How much is being collected by formal actors, by formal and eventually being managed by formal recyclers. However, we've also heard that not all e-waste is handed over to proper recyclers. About 80% is not compliantly managed. And we also need to understand what's happening with them. Is it disposed of in the residual solid waste? Is it exported for reuse? Is it not documented? Or is it being recycled but not compliantly, so handled by the informal sector? If we know that, then we can also further understand the composition of our waste. So this is one example for a country within the European Union, but we could also make this for Ghana, for Tanzania, for Kenya, for any country in this room and throughout the world. We can make some estimates on the composition of the waste. So this is for one category. I think this is for the category screens and monitors, which contains plastics, which contains ferrous metals, some aluminum, some displays, some printed circuit boards, etc. This is the bill of the materials of the waste stream in Europe. And you could then further zoom into specific components or specific fractions which are more problematic than others. And in particular for the POPs, it's the plastic fraction. In the guidelines, which I've shown earlier, we have also published on what's known in the literature on this plastic fraction, where we can find which POPs and which concentrations are in that. So you could find that in those guidelines and perform these calculations yourself, or ask us to assist you with that. With the information in the statistical guidelines, we have also highlighted some UNU keys, some products which are suspected to be most problematic in terms of the POPs and how it links to the official statistics, and which concentrations of POPs could be found in those UNU keys. And you could find this in this publication on the right-hand side, and even more toolkits have been made by our team, by the Sustainable Cycles team, to actually perform and guide you making actually these calculations. It is not, well, these are not toolkits which are showing you have to collect that, and then they are not giving you any advice on how to collect it. No, these are toolkits which are saying this is something you have to collect. This is where you can find data, and you will have that data. And if you don't have that data, we have estimates for you in order to help you. So these are so our respondents are usually saying it's very helpful to be using these toolkits developed by our team. In the end, we also want to know how much is being recovered and how much is not being recovered, how much is being safely managed of these POPs, and how much are unintended released. Maybe some findings of what we could do, or how this method could be useful for you. And I'm just showing some findings from the Global E-Waste Monitor. Right now is that right now the world is generating 62 billion kilograms of e-waste in 2022. That's 7.8 kilogram per person every year. Only 22.3% of this e-waste is managed in a compliant good way. So the vast majority is unmanaged. Unfortunately, the e-waste, the management is continuing to grow. It's gonna hit almost 82 billion kilograms by 2030. Well, the good news is that if you look at the bottom here, that the formerly managed e-waste is also growing. It grew from 2010 to 2019 from 8 to 13.8 billion kilogram. However, the rate, the speed, how fast the compliantly this compliant managed e-waste is growing is 5 times slower than the mountain of e-waste. So with the current speeds, we are just simply losing the battle, unfortunately. So we really have to change this tide. It's very important to have legislation. You'll see in this graph, on the left-hand side, each dot represents one country. If a country is having a legislation, the collection rate is much higher. It's 25% on average. If a country does not have legislation, well, then the average is 0%. So legislation and measurable targets are key for having a very high collection rate, and also having statistics is key in order to increase the collection rates. However, if you have legislation, you will also see many countries which are having hardly any collection. So it is not a cure for all. Still, you have to implement all of these things. So just having legislation and doing nothing, it's not going to be enough, unfortunately. But I think we all knew that answer. At the same time, we also know what the richer a country is, the more e-waste is being generated, which you can see on this graph. Although it does also seem to level off. If you're extremely rich in countries like Qatar or some countries in Europe, we're not buying 5 dishwashers per year. Or even though we could afford it, we are simply not doing it. So it does also level off after a certain level of income. Another aspect which is important is the transboundary movement. Not all e-waste is managed within your country. So there's a lot of compliant management happening in another country. Waste printed circuit boards are shipped to the smelters, and it's a global market, which is good. However, out of the 5.1 billion kilograms of transboundary movement of e-waste, 65% is uncontrolled and not documented. And these not documented flows are mostly going from the richer countries, from Europe, from Northern America, from Australia, into poorer regions, into Latin America, into Africa, and into Southeast Asia. And these are also problematic because the countries of the origin, they have proper facilities how to manage the e-waste. However, the exported goods, often exported as a second-hand product because there is a demand in those regions, are not always functioning when they arrive, and or also after a few repair cycles are not functionable anymore, ending up in an area where there's no legislation and not a proper treatment is taking place. E-waste is also very rich in resources, so you can also make money with management of e-waste. So that's why there's so many of these informal management happening. But also these formal managers are making money. There's copper, there's gold, and there's iron, and palladium, which is a true money maker, but secondly, we also want to get these materials back into circulation because some of them are pretty scarce, and we need them for also novel technologies to further digitize and go to renewable sources of energy. We need these materials, so we must recycle better also for that reason. However, recycling is not always like happening. I think like iron, copper, and aluminium at global scale, the recovery rates are 60%. For the precious metals, even though they represent a high value share, it's only 20%. So not all of those precious metals are being recycled at the global level. And there's even more rarer metals such as neodymium, such as europium, terbium, which are not recycled at all, and which are also critical for many governments because they're only mined in one or two countries, and we need the neodymium for wind turbines. We need, and we also need those for making the renewable energy a transition. So I've started my presentation with, if you have bad data, you will make bad information, and with bad information, you will have bad or no policies, and with bad and no policies, you will have bad funding, and with bad funding, you have bad data, and this is a downward spiral. And I will now show you also one example on how to turn this negative spiral into a positive one. It's from my home country, where I started also the work on the waste. Like more than a decade ago, we published this first publication with a mass balance on the Netherlands. We made some calculations with a team, and we calculated that approximately 1/3 of the Dutch e-waste was managed by the local recyclers, and 2/3 were missing. And as the Dutch, we always thought that we had the best system in the world, but 2/3 of our e-waste were leaking away. Well, the Dutch government first, they didn't want to believe it. However, the producers wanted to know the facts. So we made this study with them, and then we could make a baseline study. Well, these are the facts. 1/3 is collected and 2/3 are not. You may not like it, but these are the truths. Well, yeah, but this is the truth. With this baseline study, many actors in the country have started to act. It's the Ministry for the Environment and the inspection, all the municipalities, all the retailers and the producers and the recyclers. They all wanted to do better. They were using these numbers with action plans. You're responsible for that. I will do this. And they made plans. And they also have improved their statistics. And also have introduced some legal changes which went beyond any requirement from the European Union. So with this collective effort, they have improved their systems, and I will demonstrate it with this. Over the time period from 2010 up to 2019, the growth in e-waste generation was approximately 2 kilogram per person for the world, for the European Union, and for the Netherlands. Kind of the same. In the same period, the global growth in e-waste collection was only 0.5 kilogram per inhabitant. What I showed earlier, e-waste is outpacing the growth of the management, unfortunately. For the European Union, which has a strong legislation, we're doing it somehow better. But still, the growth in the e-waste mountain was the same as the growth in the e-waste collection. In the Netherlands, as a response, the growth in e-waste collection was twice as big. So they have improved their systems in a data-driven way. And you could also find other examples and the numbers of your country, of your region in the global e-waste monitor series, which is like a lot of global monitors, some regional monitors, and also national monitors. We have made many of them. I invite you to have a look and get inspired to make data and to improve your systems. A final thing. We're not there to just throw numbers in the world and then say also good luck. We also have statistical guidelines to help you with the data production. We have also tailored tools to help you to make these data sets where you can insert the data which is available in your country. Deep dive into hazardous and also valuable materials, and all of this. The training material is freely available with manuals. Maybe not a good business model, but it's helping the world. And of course, we're also there to further help you with anything else. So with that, I hope to have convinced you that we can change this negative downward spiral into a positive one. Because if you have good data, you can make really good information. And with good information, you make better policies. And if you have better policies, you can also make money with recycling, more of your e-waste in a proper manner. You will also get more materials back into circulation. So then you also can have some good funding in order to maintain these policies to work, but also to make even better data, which is a virtuous cycle, which needs to be sustained. And with that, we're also going to recover more of the materials and have less pop releases into the environment. Well, thanks a lot for that. And I think this is, in view of time, I'll skip that and also hope to hear from you after this webinar.
Great. Thank you very much, Kees. And I think your presentation did a couple of things and certainly reminded us of that the challenge of e-waste is going in the wrong direction in terms of its generation. It's still going up. But I also take away a bit of a good news message. There are tools available. There are opportunities and ways to help us address the challenge that is continuing to increase at this time. So thank you for that. I'd like to move to the discussion session now of the webinar, and this will have two components. We do have a discussant who will be bringing a few perspectives to the topic and to what we've heard from the presenters, and then we'll have a time for some dedicated questions and answers and discussion with all of you, the participants. But I'd first like then to introduce our discussant for this session. His name is David Ongare. He is the Director of the Environment and Social Safeguards Initiative at the National Environment Management Authority, NEMA, in Kenya. He is also the project lead for the Environmental Health and Pollution Management Program in Kenya. And as such, he's playing a role in projects that are working on mercury and unintentional POPs, the development of pilots on alternatives to reducing mercury use, and policy interventions on mercury and e-waste management. This is also being, in the Kenyan context, being translated into regulatory instruments, which includes the development of e-waste regulations and extended producer responsibility regulations. So David, I'd like to welcome you to the discussion. In view of the time and in view of looking to have a discussion with the participants, I'd ask you to limit your remarks to about 7 or 8 minutes, if you could do that, please. So David, the floor is yours.
Thank you very much. Am I making a presentation or I share the experiences from Kenya?
I believe the presentation is showing on the screen, so you can use those slides to move along.
Right, Stephen, maybe you can move to the next slide if you like, if it's possible. Yeah, I come from the Environment Agency in Kenya, and we are basically in charge of supervision and implementation of environment policy. Next slide, please, Stephen. So from our experience, we know that we needed to focus a little more on the interface between e-waste, because mostly we have tried to focus on it as a solid waste problem. But we see that there is this interlinkage with chemicals, public health, air quality, and UPOPs. Next slide, please, Stephen. So this siloed approach to management of e-waste has been the major challenge here, because initially we usually used to look at it as a solid waste issue. But now we are trying to look at the interlinkages with the other aspects of environmental media, specifically with chemicals and air quality. And we are seeing that in Kenya, the informal sector has been expanding quite a bit. And we know that then there is quite a significant exposure, especially of the marginalized groups, the waste pickers, the informal pickers to UPOPs. And we have seen that the general waste policies are not enough. They're not targeted enough. And therefore, we saw the need to explicitly talk to the topic of UPOPs so that we could stop harmful practices at source. Next slide, please. So before strengthening our regulatory framework, we needed to understand the specific sources of these UPOPs, the groups that were exposed, look at the pathways, what measures are enforceable and what measures are not, and generally look at measures which might simply push the project further into informality. Next slide. And one of the key planks that we use was to use a regulatory impact assessment approach really leveraging aspects, strong aspects of public participation, doing cost-benefit analysis, distribution of impacts and equity considerations, bearing in mind that it is mostly the people at the bottom of the food chain who are also mostly affected by the impacts of UPOPs, risk analysis and mitigation, and critical policy considerations so that there is a coherence with regard to the policies that we are bringing on board, not just adding policies for the sake of adding them. Next slide. Next slide, please. So we had mentioned before that we have rolled out an extended producer responsibility scheme. And we want to shift the issue of UPOPs and e-waste away from informal handling and open banning. And the key planks in our EPR operations includes the polluter pays. And we expect anyone who is producing or introducing products into our market to be in charge of these products throughout the life cycle, including the end of life handling of the waste. And we have established take-back schemes. In this instance, also mainstreaming what we call a deposit refund system. So these informal groups who are picking this waste, if they take back these materials, they are able to make some kind of livelihoods out of this, but we are also making sure that that is done in a fairly safe environment. Next slide. So we have also looked at some of the design issues. We designed for waste minimization. We designed for reuse, recycling, recovering and use of secondary materials and end-of-life management. And as the previous speaker said, we are also currently really stressing the importance of data, baseline, safe handling. And the country has also set up national targets with regard to waste reduction, waste recycling, and waste reusability. Next slide. So we have looked at some of the relevant issues that might help us to move our discussions forward. And we looked at linking these regulations so that we integrate them. And the old regulations such as the environment impact assessments and audits, our chemical management regulations, our air quality regulations, extended producer regulations, and we also have deposit bonds regulations, which act as some kind of insurance for some of these industries in the event that there is an incident that needs to be arrested quickly. Then they use these deposit bonds to try and clean up the environment. Next slide, please. Slide, please. So currently, all these regulations are under implementation, and they are moving fairly well. Stakeholder consultation was very, very important, and we have discussed with a whole array of stakeholders. I need to confess that these discussions were not always easy, but we found them to be a way to also build trust and also build awareness and openness in the way we handle e-waste and UPOPs in the country. Next slide, please. So we looked at some of the benefits of our consultations, especially in refining regulations, building trust, strengthening our regulatory impact assessments, and awareness raising. And we saw that understanding UPOPs risks is often an important trigger for behavior change in our context. Next slide, please. So we see that regulations and consultations alone are not enough. So we are also looking at ways to build capacities of various sector players. And in this context, we have also trained over 105 environment inspectors from various agencies regarding systematic monitoring of UPOPs across various sectors. Next slide. If we expect people to stop the open banning of e-waste, also it is important that alternatives are given. To this end, we have rolled out quite a number of initiatives. At the moment, we have e-waste collection facilities across the country. We have introduced and legislated waste color code. So waste is also segregated at source. One of the key exposure areas has been the open dump sites that we have across the country. And we have given some minimum specifications which will lead to the phasing out of these dump sites, but they are currently all secured, and materials that go in there are also quantified and segregated. We are moving towards rolling out material recovery facilities so that important fractions of materials are not wasted. Then there are many agencies of government collaborating and also together with the private sector, looking also at the key element of monitoring and data collection. Next slide. If we look at our context, therefore, we saw that we could not address e-waste by looking at the general regulations of waste that we have had since 2006, but we needed regulations that spoke specifically to UPOPs. We saw the importance of impact assessment to strengthen regulations and enforcement. Consultations and collaborations support compliance and transition, and regulations must go hand in hand with capacity and infrastructure. Next slide. So thank you very much. That's the end of my presentation.
Thank you so much, David. And thank you for bringing now this topic very much down to a country level, to a practical level. And I think especially in your concluding slides, some lessons from the experience in Kenya that the topic of e-waste and UPOPs is very specific, and it needs its own specific legislation and focus from the regulators rather than letting it just be part of the broader waste discussion. So thank you for that. We have now about a little more than 10 minutes, maybe 11 or 12 minutes for some questions and answers and for some discussion with the panelists. There will be two options for you to provide your questions. One is you can, if you'd like to ask your question in person, please raise your hand and we'll take questions from you. The second option is to ask your question either in the chat function or in the question and answer function, and we can read those out for the presenters to address. So please use either of those approaches. I'd like to start by taking questions directly from the floor, and then if we have some time, we'll come also to the questions that were added in the chat. So I have already someone with a raised hand, and I see it's Tadesse from Pan Ethiopia. Tadesse, please, you have the floor. Tadesse, would you like to? There you are, I think. We can't hear you. Are you able to unmute your microphone? Perhaps I could ask you if there's a technical problem, could you put your question into the chat function, perhaps? Okay, perhaps while we're waiting for Tadesse to pose his question, I can move to one of the questions that we had via the chat function earlier. I might direct this one to Heidi. And that question was, when we say persistent chemicals, for how long do these e-waste origin chemicals linger and are circulating within the environment? Heidi, is that something you perhaps could tackle?
Yeah, scientifically, there is some discussion and actually a project underway to define persistence. But I mean, in principle, the POPs have a long half-life in humans and bioaccumulate also in humans. And from that point of view, it is a concern, and the time is several years, and they bioaccumulate with with age and with exposures. Exact numbers cannot be given from that point of view, but the linkage when it's in humans, or if there's a fact, we cannot say that it's from e-waste burning or something like that. That is the problem. So to trace back, it is a chemical characteristics, and there is good reason that they were listed under the POPs convention, and from that point of view, all of them should have half-lives and stay in the environment and in humans and animals to cause concern and initiate action.
Okay,
There are
thank
scientific publications, so from one of the few ranks, 15 years in humans half-life, but then the concentration goes down to half of the concentration, and then another half from that point of view. Yeah.
Okay, thank you very much. We have another question that came through. Kees, I might direct this to you. It's a question about rare earth elements from e-waste, gadolinium, lanthanum, and cerium. These are now associated with some potential health effects. And are they still absent from most of the e-waste risk frameworks? And if so, why?
It's a very good question. I'm a chemist myself, although I never really specialized into all these healthcare issues. So I am usually relying on experts like Heidi or like others to do any sensible statements on that. So I'm afraid that I'm not the right person to answer that. Yeah, I'm sorry.
Heidi, any observations, or shall we move on to the next question?
I think that is in general a bit of the problem. When you cannot measure it or something like that, then it does not make sense. And I think e-waste per se, like fly ash or something like that, as a waste stream is a concern, and you do not need a mercury measurement that needs to be confirmed by a dioxin measurement and a brominated flame retardant measurement or something like that. So from that point of view, it's a bit a different issue from the waste management point of view, and then from the individual context. And from that point of view, first of all, it's not easy to measure these elements. And then there are still mass concentrations of toxic elements in the e-waste that are of more concern, and therefore may serve better as a trigger for action, or to identify hotspots or something like that. But individual measurements I don't have, but it's certainly not easy to measure these, and especially I think what should be mentioned as an analytical chemist in waste or in products, we do not have the sensitivity and the selectivity like we have in the environment, in human monitoring or in food monitoring or something like that. That is orders of magnitude different. And from that point of view, also the methods may not be really developed.
Okay, thank you, Heidi. We have some sort of more policy-oriented questions coming in now, so I'll put them out just generally to whoever would like to take them. We have a first question about where do you see the primary responsibility of governments in ensuring POPs data from e-waste is generated, sustained, and shared, and how can they better coordinate across agencies and stakeholders to make this happen? Anyone who would like to tackle that one? And David, feel free to come in also from your experience in Kenya on what the responsibility of government is in involving other agencies and stakeholders.
Yeah, maybe. Well, I can give this a first, try. I think the overall, management of e-waste, it should be monitored, by the government with assistance of the producers and the recyclers, because ideally there's some legislation and the producers are paying for the products they are placing on the market, ensuring that all the e-waste which they generate is being collected and managed in the right way. So I think that part of the data collection, it could be a responsibility of course, the end responsible is the government, but it may be partly delegated to some EPR schemes or to the producers and the recyclers to add data to that. On top of that, I don't think I also think it is it's a big responsibility from the producers to inform what substances they are using in their products. At this stage, they are not really doing that. They leave it up to the waste management phase, and then at the end of pipe, through laboratories, either researchers or government agencies have to find out what products they have to deal with. So I think for the legislator, I would be very strict on making also like very clear, what are you placing on my market? What do we have to deal with, and how can we make you also either responsible or just ban it, because we don't want this on our market. So I think this is the first responsibility which I could see from the government, to be strict to the producers, because otherwise you're always at the end of the pipe losing the battle, because it's very difficult to know where to find the hazardous substances. Yes, you can do it, but it may be much easier solved if you solve it at the beginning by just phasing them out from the production, and then not having to manage with them later. But still, there is a lot of like legacy waste, and I think also then the governments have to take some responsibility here, but also working together with the producers and the recyclers to solve this legacy waste, which still contain substances which we don't want.
Okay, thank you. I see I want to come back to the first question from Tadesse, who wasn't able to ask it live, but he has put it in the chat. So I'll come back to that first question. And the comment is, there are good national regulations that include extended producer responsibilities, EPR, in them, but the enforcement is low. So is there any move to enable country-level capacity building to enforce the regulations? So question not just about regulation, but also the enforcement. Anyone who would like to address that one, please.
I think we must look at what the benefit of compliance is. We must educate the regulated community on what the benefits of compliance are, and what the duty of care is for the products they produce into our market. We use enforcement in a graduated manner. We also have in Kenya what we call a compliance assistance, where there could be part of the community who want to comply, but they need some kind of support in a graduated manner with milestones to reach the targets that we want. So we put them in some kind of program to assist. But what Tadesse says is very important, that the enforcement part is graduated, but we must make sure that it is done. We are trying to set up a system in the East African region, a regional network for compliance and enforcement, to exchange experiences and capacities on how to do monitoring, and also to use the same standards within the region for inspections and enforcement. And I think if we have the right capacities and we have the right tools and the right trainings, but most importantly, sometimes we have seen that the people whom we are enforcing upon do not see the benefits of compliance. What contribution do they have to make to a better world, or to a clean and healthy environment? So that part of continuous communication and engagement is very, very important. But of course, it remains an ongoing discussion in many parts of the world. Thank you.
Thank you very much, David. We do have some more questions coming in, although I'm afraid we are getting very much towards the end of our time. So I think we'll have to ask the organizers to keep those questions for future reference. But I'd like to move on to the closing session. I'd like to thank David and Kees and Heidi very much for your presentations and for your reflections on the topic today. It's unfortunate we don't have more time because clearly there is more interest on this, but I think we have to move on to our wrap-up session now for today. And for closing remarks, I'd like to first invite Mr. Frank Fragona. He is a lead environmental specialist at the World Bank, and he'll provide us with some closing reflections from the perspective of the World Bank. So Frank, over to you, please.
Well, thanks so much. It's been great. I want to thank everybody for their active participation. I'm sorry that we weren't able to get to everybody's questions. This has really opened up a tremendous amount of interest and in all of you. And I hope that you can take this forward as well, what you've heard today, and with a lot of enthusiasm. We'd like to, thank the UNITAR colleagues for their coordination efforts, and my other colleagues in the World Bank as well. We heard some valuable insights into POP's international regulation and the consequences of informal e-waste practices. We have heard about the major health and environmental risks, particularly in countries where informal recycling dominates. The implementation and enforcement of international conventions needs to be strengthened, we've heard as well, to eliminate or restrict POP-containing materials. Many parties now, 191 parties to the Basel Convention, with the 2022 amendments requiring all e-waste undergo the prior informed consent, but we know that the enforcement gaps persist, particularly from where I sit in the Africa region that we're hosting this webinar, as the continent becomes more urbanized, because it's going to be the continent that urbanizes the most. And we heard earlier about how there is a correlation in terms of the urban dimension and the e-waste increasing as a fraction of the total waste stream. It's something that we really need to think about, especially in this continent. It's important that well-regulated treatment systems are implemented to help reduce the POP emissions, as we've seen from the China Jeff UNDP project, demonstrating that replacing informal recycling and integrating EPR significantly lowers the generation of these POPs. I don't want to take a lot more time from everybody, but I think that the insights today, remind us that strengthening e-waste and POPs management is not only a technical challenge, but a collective responsibility, one that protects communities, preserves the environment, and supports a healthier and safer future for all. Last but not least, I want to remind you that the presentations and recordings are on the EHPMP website, which is an interesting source of information, especially for those of us working in the Africa region. And on behalf of the World Bank, we'd like to thank our colleagues from UNITAR especially. They're a great resource as well. Please look at their websites, and I'd like to thank Jonathan Kruger, Stefan Joyce, Oliver Wooten, and all the UNITAR colleagues involved in preparing this session. So with that, I'd like to thank you again, and hope to see you again soon if we're able to in a future webinar. Thank you.
Thank you so much, Frank, and thank you for the World Bank for sponsoring this. I'd like to give a last word to the other co-sponsor for this session, which is UNITAR, and Oliver Wooten, who's a Senior Program Officer at the Chemicals and Waste Management Program at UNITAR, has a brief final word for us, please. Oliver.
Thank you very much. Yes, so I won't sum up much of the webinar today, but just general thanks. And as you mentioned earlier on, this is part of a series. So we're very grateful, and I'd like to thank the World Bank for the opportunity to undertake this collaboration and help share insights and knowledge coming out of the EHPMP project, as well as broader global activities, as we've been able to bring in other speakers and presenters. I am certainly therefore grateful to all presenters, panelists, and discussants for giving their time and expertise. That is today, of course, and across the other webinars, as well as my UNITAR colleagues in setting up and making these sessions possible. It has been insightful seeing different elements of waste from hospital settings, e-waste and mercury pollution, as well as other chemical pollutants such as POPs, and some of the steps that can be taken to mitigate the worst impacts and find more sustainable solutions. We have shared this knowledge across the first 3 webinars with some 750 attendees, and I noted today over 180 more joined us. This is a great example of the demand for knowledge sharing that Frank mentions, and the benefits of tools such as webinars to help spread messages and outcomes from programs. Furthermore, the World Bank UNITAR series is a further step in the long-standing collaboration between these 2 entities, and an example of the work that is done by IOMC organizations. It is worth highlighting here the efforts of the IOMC that we are undertaking to support the development of implementation programs. And this has particular relevance for the electronic sector, circularity, and working with those private sector entities. I noted many chat messages, questions related to that, and I think some of those broader elements will come out during those implementation programs. I remind you that information on this series of webinars is available on the EHPMP website, and we hope to engage with as many of you as possible in the future, whether it be on webinars, workshops, directly in future projects, or helping to share information. UNITAR's Chemicals and Waste Management Programme is always open to offer advice, guidance, use of our materials, and discuss new opportunities. We also posted in the chat the links to our previous work with the World Bank on EPRs. So thank you once again for today and this series, especially our contacts at the World Bank, including Frank, Lolwa, Ketty, and Mohammed, and for the previous good working relationship with Ernesto. For today, goodbye from me, and back to Jonathan to close up. Thank you.
Thank you so much. I think with that, we'll close today's session, and thank you all very much for your participation, and we look forward to seeing you again at a future event. Thank you, and enjoy the rest of your day.